Hi Year 12s, I'm not in class today, so I thought I'd make you a very short video just to talk about what you're doing today. So we spent a bit of time looking at quadratics and finding their inverses last lesson. Pause the video and have a go at the starter, that's on that same topic. Okay, hopefully you've had a go at that. You should be able to find the answers on our OneNote. So let's keep going through this. So we are looking at fitting quadratic models today. We will come back to this topic a little bit later when we look at regression, but for now we're just going to focus on a slightly more algebraic approach. So if we think about linear functions first of all, if we know 2 points, then we know that there is one straight line that goes through those 2 points, a unique linear model. If we only had 1 point, however, there would be too many options, because really we can draw like an infinite number of straight lines that go through that 1 point. If we know, let's get rid of some of these, if we know more than 2 points, if we know 3 points, then perhaps we're not going to be able to find a line that goes through all 3 points, but I'm sure you remember doing this in science of finding a line of best fit, so that could be what we try there. So if there's just 1 point, there are many linear models, and if there are more than 2 points, then we should, for now I'm going to say find a line of best fit. In our next unit, we'll start exploring something called regression, and we'll talk about how to find a slightly more accurate version of a line of best fit. Okay, so if we've got quadratics, so we can't have a unique quadratic that goes through 2 points. There's too many options. We could have a quadratic that went like this, we could have a quadratic that went like that, we could have one that went like this. There's too many options. So we actually need 3 points. If we've got 3 points, there is a unique quadratic that will pass through all 3 of them, and that's what you're going to explore today. So there's a little question down here about a student throwing a rock. It starts on a cliff at time 0, 20 meters above ground level. The rock goes upwards to a vertex. It then gets to the same height again, 20 meters high, at time 3.26, and then it falls into the sea over here at time 4.8 seconds. We want to try and find a function that models that motion, and we're going to assume that a quadratic function is the appropriate model for that. So we are going to try and look at how we can do that efficiently using a little bit of algebra. So we have been given the form of this quadratic, at squared plus bt plus c. Obviously we're using t's instead of x's because we're talking about time. So what we can do is we can substitute in each position that we know about. So we know that at time is 0, the rock is 20 meters above sea level. So we can substitute that in. We know the height is 20. So I have 0a plus 0b plus c. All right, we also know that at time 3.26, the height of the rock is once again 20. It's falling down. So we know that the time is 3.26. So if I substitute in the time, I will get a second equation. And then the final point we know is that at time 4.8, it's at sea level, so its height is 0. And once again, I can substitute the time in, and, oops, not 3.2, sorry, I'm just copying the line above. And I'll get a third equation. So we have 3 unknowns and 3 equations. Now, lots of you might be immediately spotting that this first equation actually tells us what c is. C is 20. So we could go through the second and the third equations and replace c with 20. Then we'd be down to 2 unknowns, just a and b, and 2 equations. So we could either solve this as a 2 by 2, like 2 equations, 2 unknowns set of simultaneous equations, or a 3 by 3 one, 3 equations, 3 unknowns. Both of them work, and we can use our calculator for this. So I've kind of screenshotted what we would do. We would go into menu algebra, solve system of linear equations. I'm going to go for the 3 equations, so I made the number of equations 3. When I clicked on variables, it automatically gave me 3 variables. And then you get the option to enter in your 3 equations. So I wrote in each of the equations. Obviously I'm using X, Y, and Z here. I guess I could have changed these to A, B, and C. Maybe that would have been nicer. But I think we're probably all pretty happy just dealing with X, Y, and Z. So you can see I've typed in the 3 equations. Hopefully they're exactly as I wrote them, aside from the A, B's, and C's. And this gives me the answer. So I know that in my context they are A, B, and C. So what am I trying to do for the question? I'm trying to find the equation. So it's going to be h of t equals, and I'm going to round all of these to 3 significant figures, negative 2.71 t squared plus 8.82t plus, and this should say 20. Okay, so this is my function. Now, if I was really unsure about this, I would probably put it in the graphing document and make sure it looks like it's following the path that we have in the diagram. I can see though that it has 20 as C, which I know is correct. It's got a negative A value, which gives me this concave down parabola, which is also what I want. So I'm fairly happy with that as an answer. Okay, hopefully you'll have plenty of time to do some practice today. There are some practice questions on page 33, and I would highly encourage you to go back to last lesson and do a bit more practice on finding inverse functions as well. Okay, I'll be back in class and I'll see you on Thursday. Bye-bye.